Okay, so I think I'm on about take 4 now. I keep trying this. I'm trying to get it perfect, but we're going to have to maybe just go with it because I'm starting to get tired. Anyway, so happy Friday. I hope you're enjoying your Friday. As I told you yesterday, I'm not going to be here today because I'm at my uncle's funeral. So you guys have a video lesson. So the plus side of a video lesson is that you get to slow down or repeat or pause anything that you need as you go. The negative side is that you really can't ask questions, at least not right away. So yesterday we did rotations about a point that was the origin. So we were rotating shapes around the point 0, 0. Today we're going to start talking about rotating points, rotating a shape about a point that is not the origin. So just as a reminder for rotating about the origin, just so we get your brain kind of back in gear from yesterday, let's do an example that is around the origin. If you've got this down, you can skip forward and go right on to um, the next slide. So the first thing I need to do is plot my point. So I have the point 1, 1, 4, 5, and 5, 1. So if we plot that triangle, P is at 1, 1, Q is at 4, 5, and R is at 5, 1. This is called the pre-image. And we want to rotate it 90 degrees clockwise. So that means we're going to be going to the right, um, 90 degrees about the origin. So if I bundle this up and I spin this 90 degrees, what that's doing is it's showing you, you literally want to spin your paper 90 degrees, it's showing you where your new answer is. So if I plot, um, let me get my highlighter out. This is essentially new my new axes. It's now the horizontal one is labeled Y, but it's actually X because I've turned my paper and my Y is this way. So you're going to look at this just like you would expect to. X is horizontal, Y is vertical. So if I look at where these points are, the point, this is where I want my triangle to end up. The point P prime will be at 1, negative 1. The point Q will be at 5, negative 4. And the point R will be at 1, negative 5. So now that I know where they're supposed to end up, I can take my shape and spin it back around. Just take my little blue lines off of there so we don't get all confused. I can spin it back around, and now I'm going to plot these points. So I have the point 1, negative 1. I have the point 1, negative 1. I have the point 5, negative 4, and I have the point 1, negative 5. So I said that I thought this would end up in the bottom right corner. That's where it should end up, and that's where it does. So it's a 90-degree rotation. You can kind of picture if you think of this triangle and it's kind of spinning its way around. So as it spins around, the P moves to here, the R kind of swings around, kind of the 90-degree kind of spin around. Okay, so now let's try the new problem. So in the new problem, we have triangle PQR has vertices 1, 1, 4, 5. P is at 1, 1. Q is at 4, 5. And R is at 5, 1. Which I think is the same triangle as the last one. But we're going to rotate it about the point negative 2, 3. So what we need to do is we want to rotate it about this point negative 2, 3. So we need to draw these new modified axes, kind of like I did on the last one, but remember the last one, it was in the same spot because we were rotating around 0, 0. So we're going to rotate around this point. So we are still going 90 degrees clockwise. So I'm going to wrap this all up so I can spin the whole thing together. So if I spin it 90 degrees clockwise, the answer I should end up down here. Then you remember you're just looking at the blue axis here. It's down here at the bottom, halfway between the third and fourth quadrant. So if I look at where these points are, I'm looking off the blue axis or my modified axis. So the point P is at negative 2, negative 3. The point Q is at 2, negative 1, 2, 3, 4, 5, 6. and the point R is at negative 1, 2, 1, 2, 3, 4, 5, 6, 7, negative 2, 7. So this is where we want it to end up. So now that we have those coordinates ready, we're ready to spin it back, to put our paper back to normal. And remember, these are modified axes coordinates. Modified axes coordinates. So we're going to measure everything off the blue axes. So if I go to plot those points, I need to plot the point negative 2, negative 3. I need to plot the point negative 2, negative 3, that's my P prime. 2, negative 6, that's my Q prime. And negative 2, negative 7, that's my R prime. So you can see it's in the bottom. It's underneath, it's halfway between kind of the third and fourth quadrants. It's underneath the blue one. If you spin your paper back around, you can look at where does this one go. It looks almost exactly like this. Look at it, where is it relative to these blue axes? So it's directly below, halfway, pretty much halfway between the two quadrants. Okay, so the only thing is that's not really what the modified axis is, a real axis. It's like a pretend axis that we use to figure out where to rotate this. The real axes are still, come on, I had it all drawn so it would draw really nice and pretty, but maybe it's not going to for me. Your real axes are, right, the big black ones that we have right here. So when we start talking about the coordinates, we need to look at the real axes for our real coordinates. So when I'm looking at these points, P prime now is at negative 4, 0. Q prime is at 0, negative 3. And R prime is at negative 4, negative 4. So your final answer is measured from your real x-axis. But all of the work and trying to figure out like where the points go, that has to be based off the point that you're rotating about. Okay, let's try another one. So this is quadrilateral MNPO, and let me get it up there. So there's quadrilateral MNPO with the coordinates that are given, and we want to rotate around the point 3, 1. So I want to rotate around this point where I put the new blue axis. This is the point 3, 1. So that's what we're going to spin around. And in this case, we're going to rotate 180 degrees. So we're going to turn our paper essentially kind of twice, 90 degrees each time. And so let me gather all this stuff together so that I can spin it 180 degrees. Miss the clicks, but that's okay. So this is where our answer should end up based on the blue axis. So it should be above the origin of the blue axis. The P should be pointing up, should be kind of straddling the two quadrants. So if we measure these coordinates, M is at 2, 2, N is at negative 2, 1, 1, 2, 3, 4, negative 2, 4, O is at 2, 5, and P is at 0, 8. So this is all based on the blue axes. So now that we know where those are, we can turn our guy back upside right where he's supposed to be. So we just turned him over just to see where the answer should end up so that we could write down the coordinates. So now we can plot them. Now these coordinates are still the modified axes, so we have to plot it based on the modified axes. So when I do that, I'm going to plot 2, 2 off of the blue axis. So right 2, up 2. N prime is left 2, negative 2, 4. O is 2, 5. And P prime is 0, 8. That's exactly where we said it should be. It should be above the blue axes. It should be the blue origin. The P should be pointing up. It should be kind of straddling the two quadrants, exactly where we wanted it to be. Now, one thing that's kind of cool with 180 degree rotations, that if you look from M to M prime, it goes right through the origin. They're essentially the same distance from the origin. And so N, if you draw a line from N to N prime, it goes straight through the origin. P to P prime goes straight through the origin, and O to O prime. That's true as long as you're rotating 180 degrees. It's not true if you're rotating different lengths. But for the 180 degrees, it's kind of neat how it comes out. You can kind of see the rotation from here spun up to there. Now remember, our final answer has to be based on our real axes, right? We can't use that fake blue one. That's just to figure out where the answer is. Your final thing has to be on the real ones. So if I use the real axes, M is at 5, 3. I counted right. N is at 1, 5. O prime, sorry, is at 5, 6. P prime is at 3, 9. So here are the coordinates of our new shape. Okay, one last example. This one is also a triangle. We have triangle ABC. The coordinates are 3, 2, B is at 1, -1, and C is at 0, 4. So we graphed it, and we want to rotate about the point -1, 2. So we want to see our blue axes. This is what we're rotating about. And we're going to we're going to do 270 degrees counterclockwise. So that means I'm going to the left, and I have to kind of do three 90-degree turns. So I got to turn my paper 90 degrees 3 times. Kind of roll off the page. So you can either turn it, whoa, didn't want to actually move that. Let's try that again. Start from up here. You can either go 1, 2, 3, go 270 degrees to the left, or that's the same thing as going 90 to the right. So it's still kind of, you can see that it's down underneath the axes, kind of see where that is. And if I went, I didn't quite go far enough, there we go. If I go 270 counterclockwise, 1, 2, 3, it's still going to end up in that same spot. So you can kind of adjust which way you want to go. Now that I have that, this is where the answer is going to be. It's going to be below the blue, or the modified blue axis origin. It's going to be straddling those 2 quadrants. So I need to write down those points. Once I have those points down, the only reason I turned my paper was to figure out where those points are. Now we can turn our paper backs upright, so we have things all oriented the way they are. And we just need to plot based on this blue axis. So based on the blue axes, A prime is at 0, -4. So based on the blue axis, so 1, 2, 3, 4, it's at 0, -4. Based on the blue axes, the B is at -3, -2, and the C is at 2, -1. So this is our rotated shape. Now, of course, we can't use blue axis coordinates for our answers because it's the modified one. It's not real. It's just a tool that we use. So we have to write our final answer based on the actual real axes. So A prime is at -1, -2, B prime is at -4, 0, and C prime is at 1, 1. Okay, so there's a couple of examples for you. You do have some practice to kind of work with. Feel free to come back to the video to kind of watch and see, okay, how did that work? And you can go back and kind of look and kind of see how it goes. Don't forget that your cumulative review is due Sunday at 5 o'clock, so don't forget about that. And then you have the rest of the bell to work on it. Whatever you don't finish on this rotation paper is homework. I hope you have a great weekend, and I will see you Monday.